So the question that everybody is asking is, how do we determine what order a set of data follows? And that's really the whole purpose of integrated rate law. So let's take some data. Okay? What we're going to try to find out is, what is the order of this reactant? And there's a couple ways that it can be done, but we're going to use our calculator. Okay, I'm going to make this as big as I can, and I'm going to put this over here so you can all see the data. I want this bigger, and I guess it's not going to let me do that. Okay, well, it was fun trying. Okay, so you've probably done some graphing on your Texas Instruments calculator before. It's a pretty powerful graphing tool. Here's how we're going to do this, and I will include an attachment in OneNote on how all of this works. But what we're going to do is we're going to enter some statistics. Okay, so I'm going to hit the stat button right here, and I want to edit this data. There isn't any yet, but what we're going to do is attempt to determine the order of this data using a graph. So here's the key. The graph that gives the straightest line that gives the straightest line determines the order. Okay, and here's how this works. If a reaction is zero order, then a graph of time on the x-axis versus the concentration of our reactant on the y-axis will give us a straight line. If the reaction is first order, then a graph of time on the x-axis versus the natural log of our concentration will give us a straight line. And finally, if the reaction is second order, then a graph of time on the x-axis versus the inverse of the concentration will give us the straightest line. So let's take this data, and what we're going to do is we're going to enter it into our calculator, and we're going to ask the calculator to graph it for us. And the arrangement of the calculator that gives us a graph with the straightest line determines the order. So I'm going to enter time on the x-axis. It really doesn't matter what column you put it in, because you can determine what is on what axis when you graph. I'm just used to putting time in L1. So I'm going to enter in L1 these data. And as you can see, I'm entering the data into column L1. I'm entering the value, and then I'm simply clicking down on the cursor. And this is how I get my data into the calculator in such a way that I can graph it. Now, you've probably done this before, and if you have, great. If not, this might be your first time. All right. Now, we're going to put concentration on the y-axis, and we're going to do that by putting it in L2. So there are ways to speed this up, and you don't have to enter the 0, and you don't have to enter all the trailing zeros, because the calculator will do all that stuff for you. I did not want this in that column, so I'm going to delete it. And now we want to be in L2. So I'm simply scrolling over to L2. Okay. Now I'm going to enter the data for the concentration in L2. I don't know why I did that. I'll go back to editing. Okay, so we're in L2 and we want 0.1. We want 0.0707. And I'm simply entering this data just down this column. And I'm, again, not really necessary worrying about entering all the zeros because your calculator is going to take those out anyway. So I'm kind of streamlining the process. And it's easy to skip one of these by mistake, so you may want to double check that you got them all in there. Okay? So time is in L1. Concentrations in L2. And what we're going to do is we're going to create what's called a stat plot. That's this button here. I'm going to hit second stat plot. What this is going to do is give me some options. It tells me that right now I've got 3 stat plots. They're all off. They're all graphing L1 on the X and L2 on the Y. If I highlight one, you can see that here I am highlighting 1, and I hit this button enter. It'll tell me exactly what it's doing. It's a dot graph. That's all we need. The X is currently set up to display the data for L1. The Y is currently set up to display the data for L2, and it's currently off. We're going to select on. So I'm moving, and then I want to, so notice that the cursor is flashing over on. That's the one I want. Okay. Now we're going to hit the graph button, and it's going to show us the graph of L1 versus L2. But we're not going to see anything because it is trying to show us a too fine a resolution. So what we want to do is we want to zoom out, and I'm going to zoom out in such a way that it zooms to the data. So notice that if I scroll down, here's choice 9. It's called zoom stat, meaning it's going to zoom to show us all of our data points. There are 6. This is what the graph looks like when I graph all 6 data points. And it is clearly not a straight line. So for this particular example, it can't be 0 order. So the next logical step is we're going to take this data and graph time on the X versus the natural log of the concentration of A. Here's how we're going to do that. We're going to go back to statistics, and we're going to select edit. And what we're going to do is we're going to scroll up here to column L3. Now notice that when I am highlighting L3 up here, notice that down here it says L3 equals. Well, it's asking you to tell the calculator what you want the data in L3 to equal. I want the data in L3 to equal the natural log of the data in L2. So I hit the natural log button, and then notice how these functions here are the same color as the second key. That means they are shift functions. So I'm going to hit second and this button, and that's going to tell the calculator that in column L3, everything in column L3 is going to be the natural log of the column in L2. Now watch what happens. When I hit enter, everything in L3 is now the natural log of L2. So what we want to do is graph L1, which is time, on the x-axis, versus L3, which is now the natural log of concentration on the y. We're going to hit stat plot, and I'm going to go down here to choice 2, and I'm going to highlight it. It's currently off. Notice that there are 3 plots available. Here's plot 1. This is the one that we just saw, L1 versus L2. Let's turn this one off. Let's take plot 2, and we're going to turn this one on, and we're going to instruct the calculator that in the position for L, on the y-axis, we don't want L2, we want L3. So I've got this highlighted, and I'm going to tell the calculator second L3. Now the calculator is ready to graph L1 versus L3. We want to make sure that it's on. Okay, we don't really care about colors, but this can do lots of fancy things if you want. We're just going to leave it like this. I am making sure that plot 1, which was my original graph, L1 versus L2, is off, and I'm going to highlight plot 2, which is now L1 versus L3. Everything looks good. It's on, and I'm going to hit graph. We're not going to see anything because the resolution is too high, so we are now going to zoom to the data, which means zoom to the entire statistics. Ladies and gentlemen, that is a graph of L1 versus L3. In other words, it's a graph of time versus the natural log of our concentration. That means that this reaction is first order, and that means that the rate law for this reaction is a natural log of the concentration of N2O5 is equal to negative K times the time plus the natural log of the concentration of N2O5 at time 0, which in this case is 0.1. All right, that is the rate law. Now, if I was going to ask you to find the units, the value in units of the rate constant K, here's how we're going to do this. That's K right there. It's negative. And if you notice that this equation sure looks a lot like our equation for the slope of a straight line, meaning that the rate constant K is the slope of our line. Notice that it's a negative slope because our graph is trending downward. There's a couple ways that we can do this, and I'll show you 2 of them. Okay? And we'll take a look at that in the next session.